In Module 5, Lesson 11, we're going to start looking at volume, and in this particular lesson, our measurements are going to have fractional edge lengths, and we'll also talk about unit cubes. So in our opening exercise, we're looking at two prisms, and we're asked which prism will hold more 1 inch by 1 inch by 1 inch cubes. So what we'll need to do is find the volume of each of these and then subtract to see how many more cubes the larger prism holds. Remember, to find the volume of a rectangular prism, you multiply base times width times height with 3 dimensions. So 10 times 4 times 6 which will be 240 cubic units, cubic inches. And a cubic inch is really that it is a little cube that is 1 inch by 1 inch by 1 inch. So if we filled this box with cubes that are 1 inch all the way around, it would take 240 of those little 1 inch cubes to fill this whole container. Now the second container is 8 by 5 by 12. And remember, the order that you multiply these three numbers in doesn't matter. Multiplication is commutative, so we can multiply in any order and still get the same answer. 8 times 5 is 40, and 40 times 12 is 480 cubic inches. So the rectangular prism on the right will hold more, and it holds 240 more cubic inches, which is actually twice as many as our prism on the left. Now in example 1, we have a box with the same dimensions as the prism in the opening exercise, but it's going to ship miniature dice whose side lengths have been cut in half. So these dice are 1/2 inch by 1/2 inch by 1/2 inch. We want to know how many dice of this size can fit in the box. So we know from our previous calculation of the volume that this prism is 240 cubic inches. And so what we want to do is find out how many of these, and I caution you, it isn't just going to be twice as many, how many of these dice can fit into the box. So we'll need to find the volume of each individual die and then divide our volume of our larger box by that volume of the dice. And then when we divide, there are 240 cubic inches by the 1/8 cubic inch die that we're talking about. We get 1,920 of those that can fit into the box. In example 2, we have a 1/4 inch cube that's going to be packing this prism. We want to know how many 1/4 inch cubes will it take to fill the prism. So the first thing we want to find out, or it doesn't really matter which order, but let's find out what the volume of the 1/4 inch cube is first. So we have 1/4 times 1/4 times 1/4. And remember, when you multiply fractions, you multiply the numerators straight across. 1 times 1 times 1 is 1. And then the denominators straight across. 4 times 4 is 16. and 16 times 4 is 64. So the volume of this cube is 1/64 cubic inch. Next, we want to find the volume of the prism, and our prism is 1 1/2 by 1 by 3 3/4. We'll multiply those three numbers together. So our little cubes are 1/64 cubic inch each, and our prism is 5 5/8 cubic inches. We divide the 5 5/8 by 1/64 to get 360 cubes that will fit into this prism. And we'll practice with exercises 1 through 5. Using this prism, we're going to calculate first of all the volume. 5 1/3 times 2/3 times 1 1/3. And we find the volume of the prism to be 4 20/27 cubic centimeters. If we have to fill the prism with cubes whose side lengths are less than 1 centimeter, what size would be best? So in looking at the prism, what we really want to look at is the unit that the sides that would allow those cubes to fill the sides exactly. So since our sides are measured in thirds, we would want our cube to be 1/3. That way we would be certain that we would not have any extra space. It's 1/3 this way, thirds this way, and 1 1/3 this way. So if our cubes are 1/3 centimeter, we can be certain to pack the full volume of this prism. And then, of course, we're going to be asked how many of those cubes would fit in the prism. So we would need to take our 1/3 centimeter cube and multiply length times width times height. And that would be 1/27 the volume for each cube. And then finally, we take the two volumes, the volume of the prism and the volume of our 1/3 centimeter cubes, and divide them to find out how many of those cubes we'll need to fill the prism with. And we find 128 cubes will fit in that prism. In exercise 2, we're just given a variety of different rectangular prisms, and we're asked to calculate the volume of each of them. So we'll simply multiply our three dimensions. And the volume of our first prism is 1 23/32 cubic centimeters. In B, we'll multiply 3 1/3 by 3 1/3 by 5 2/3. And in our second prism, we get 62 and 26/27 cubic inches. Our third problem doesn't have a drawing, so we'll need to read. The toy company's packaging its toys to be shipped, and some of the very small toys are placed inside a cube-shaped box with side lengths of 1/2 inch. These smaller boxes are then packed into a shipping box with dimensions of 12 by 4 1/2 by 3 1/2 inches. So we want to know how many of the small toys can be packed into the larger box for shipping. We want to find the volume of the larger box and find the volume of the cube-shaped little box, and then divide, just like we did earlier in the lesson. So our larger box is 12 by 4 1/2 by 3 1/2. And we find that 1,512 toys will fit into our shipping box. In Part B, they ask us to use the number of toys that can be shipped in the box to help determine the volume of the box. Now, while we already calculated the volume of the box, sometimes you don't know the size that your box needs to be until you calculate it. So what we want to do is take the 1,512 toys and multiply it times the 1/8 cubic inch for each one, and that will get us back to 189 cubic inches. In question 4, we have a rectangular prism with a volume of 8 cubic inches. And it's filled with cubes. First, it's filled with cubes with side lengths of 1/2 unit, and then it is filled with cubes with side lengths of 1/3 unit. They want to know how many more of the cubes with 1/3 unit side lengths than cubes with the 1/2 unit side lengths will be needed to fill the prism. So what we have then is a volume that we've already been given. And we're going to have to determine the volume of each of these cubes and divide our volume by that. So the one thing that we're not doing right now is we don't have to calculate the volume of the prism. They've already given that to us. So if we have 1/2 unit cubes, we would do 1/2 times 1/2 times 1/2, which will give us 1/8. Cubic units. And for that, then we want to divide the volume of our rectangular prism by the cubic units. So in looking back at our calculations, the 1/2 inch or the 1/2 unit cubes were 1/8 cubic units when we found their volume. Then we divided the volume of our rectangular prism, by the 1/8 cubic units each, and got 64 cubes would fit in there. The 1/3 unit cubes, on the other hand, have a volume of 1/27. And so when we divide our volume by that unit, we find that 216 of those cubes will fit in this same rectangular prism. So 216 minus 64 is 152 more 1/3 unit cubes will fit into our rectangular prism. Now in Part B, they ask us to tell why it takes more cubes with the 1/3 unit side lengths to fill the prism. And so realistically, what we were really talking about is 1/2 inch in length is larger than 1/3 inch if, if these were inches. for example. The 1/3 inch long cubes would be smaller. So it takes more of those to fill the prism. And then in question 5, we're asked to calculate the volume of the rectangular prism. And they're asking for 2 different methods to determine the volume, but one is sufficient. And this prism is 5 1/16 cubic meters.